Hey everyone, welcome back to AP Precalc. This is lesson 2.6. Let's get right into it. All right, so pause the video now and try the bell ringer on your own because I am about to go over the answer. And so the value in thousands of dollars of an investment is modeled by function I. It increases 2.9% each month of the year. The initial investment was $215,000. If t is measured in years, though, which of the following could be an expression for m of t? Know that there's 12 months in a year. And so here m of t should begin with our initial investment of $215,000, right? But it is in terms of thousands of dollars. And then our growth rate is going to be 1.029. It's not going to just be 0.029 because then you're only taking 2.9% after the first year and so on, and you're going to be decreasing really quickly, but it grows. So you need to multiply it by 102.9% each year. However, this is the percentage or the growth rate per month. So if we want to figure out what is it per year, remember there's 12 months in a year, so this growth rate is going to be occurring 12 times for a full year. And then it's going to be occurring t years is how we want to kind of measure this. If we rewrite this, this should be m of t equals 215, and then this is 1.029, and we can multiply these exponents with the power property. So this should be to the power of 12t, which matches answer choice D there. So today we're going to be talking about residuals. And so when we create a model or our line of best fit from a potential story problem, we can try to predict values like we did in lesson 1.14, right? If we have a bunch of data points, we can kind of create that line of best fit and then predict values when like maybe x equals 5 or different things like that. But that's only a predicted value. That's not the actual value that occurs in the real world or from actual data. And so is there a measure for, let's say, this data point right here on how far off we were from our predicted value? What is that distance? And that is going to be our residual. That's what we call a residual, which is a measure for how far off we were from the predicted to the actual value. And so what the residual is it's our actual value, usually given in the data or in the story problem, and then minus our expected value. And this is from our linear or exponential regression. Could also be quadratic too. And then this should equal our residual. And so the mnemonic device that I have is actual minus expected equals residuals. That's the formula for a residual, which I had a friend in high school that ran cross country with me. His name was Amir. And so it's a pretty easy acronym or mnemonic device to remember the formula for a residual. Actual minus expected equals residual. And so that's one calculation. And then from our residual, we can always find our error. And so your residual, based on if it was an overestimation or underestimation, will be either positive or negative. You don't know which one it could be based on the data and how far off your model was, but is there just a general measure for how wrong we were or how right we were if it was very small? And that's our error. So the error is just the absolute value of the residual. It doesn't matter. Basically, it's like not very much like the Price is Right, where you want to see how close you were for getting it spot on, whether you were, let's say, 0.5 away, or you were 1.2 away from the other end, right? The error here would just be 0.5, even though your residual would be negative 0.5. And our error here would just be 1.2, even though it's positive 1.2 there. So it's just the absolute value of your residual is just a general statistic of how far off we were. All right, so let's work through example 1. The weight of a newborn baby can be modeled by a linear function for the first 4 months after birth. Selected values of the weight of a particular baby is given in the table above, where t represents the number of months since birth. We want to use the regression capabilities on your calculator. That's a fancy way for saying Desmos, to find a linear equation for the weight of this baby. So let's take a look. If we actually go to this next slide here, this is what your Desmos should look like. So try this question on your own first. Plugging in your data points into the table and then going to linear regression, it should automatically be set to that. We should get our regression line right here. And so that should be our answer for part A. It should be y equals 0.8x plus 3.34 should be our answer for part A. I'm going to copy and paste that right here and then replace y with f of x. And the reason why I do that is so then I can plug in a specific value, f of 2.5. Here, for part B then, we should get, we want to use the model to predict the weight of the baby 2.5 months after birth. This should be 5.34 kilograms. So that is going to be our answer for part B, 5.34 kilograms. For part C, we are given that the actual weight of the baby was 5.12 kilograms. What is the residual for this weight? So remember, residual is actual minus expected. So our actual weight was 5.12 minus our expected, which was 5.34. And so our residual should be here, let's see, negative 0.22 should be our residual there. And so that should be our residual, negative 0.22. Part D, did our model over or underestimate the weight of the baby 2.5 months after birth? So here we expected it to be 5.34 and the actual was 5.12. So even though we have a negative residual, this was actually an overestimation. So I would say overestimate. And then part E here, what is our error with a baby 2.5 months after birth? That is going to be the absolute value of our residual. So the absolute value of negative 0.22 is 0.22, and that should be our answer for part E there. All right, so let's take a look at an example of a residual plot. So let's say point Q is at 10, 4, this point right here on a residual plot. Then for whatever model is used, we don't know that information, whether it's linear, quadratic, exponential, cubic, it doesn't matter. At the point x equals 10, right, at that value, x equals 10, the actual data point is 4 units above the expected data point, right? Because remember, actual minus expected equals residual, which in this case, our residual is 4 from the residual plot, which means the actual should be 4 units bigger than our expected value. So here, this would be an underestimation. When the actual data point is 4 units above the expected data point, right? The actual is way higher than what we expected. This means that we underestimated the data point by 4 units. So underestimated the data point at x equals 10 by 4 units. But the main thing here is, notice there's a positive residual, which means that it's an underestimation. That will always be true. Whenever the residual is positive, it's an underestimation. Whenever the residual is negative, that means it will be an overestimation. So that's something to remember, especially for your next test. And so using a residual plot to check the appropriateness of a model, a residual plot shows the residuals for a set of data and can be used to help determine if a model is appropriate or not. Pretty much just remember this. If a model is appropriate, then the residual plot should appear completely random. There should be no pattern whatsoever. If there is a clear pattern in the residual plot, then the model that was used was not appropriate, right? So let's take a look at what that means. If let's say we have an actual, so this is different from our actual data, and then let's convert this to a residual plot here. So let's say our actual data was like this, right? And our linear, and let's say our line of best fit was that line. Obviously, that's not a great line of best fit because we can, it should be moved up a little bit. What the residual plot would look like is if this was 0, the residual plot would just be a straight line like that. That's not good, right? There's a clear pattern. It's a straight line. You would want the residual plot ideally to look just completely like random, like a 5-year-old almost drew on it, right? And so here we could see a clear pattern, which means that is not our like line of best fit. But here there's no pattern, which is kind of what we want, right? Let's take a look at if we have another data set and then what the residual plot may look like. So here, let's go, I'll go blue now. Let's say we have this line of best fit, and then we have a few data points here. The residual plot should look like that, right? It looks kind of random. There's no pattern. It's just hodgepodge numbers. That's good, right? That means that's a pretty good line of best fit, which is kind of what we want to see. All right, so just remember random equals good for residual plots. All right, so take a look at example 3. This is the type of question that you can see. So an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. Which of the following conclusions is the most about the appropriateness of an exponential regression is correct? And so, let's see. Here, there's no pattern, which is a good thing, right? That should be an N, which is good, which means the model is appropriate. So we can eliminate A and B. And so the model is appropriate because the residuals show no pattern. So C would be our correct answer here. Example number 4. A group of AP Pre-Calc students used a set of data to create linear, quadratic, and exponential regression models. After creating the 3 models, the students created a residual plot for each model type. Based on the 3 residual plots above, which model is the most appropriate for the data? Give a reason for your answer based on the residual plots above. So here, you can kind of see a clear pattern in the linear and in the quadratic residual plots. However, in the exponential, this appears very random, which is good. So thumbs up there. And so when it's a pattern, you will clearly see the pattern like in the first 2. And so the best model to use is the one that is appropriate, exponential. And remember, these are residual plots. These are not the actual lines of best fit. Those are 2 very different things. So exponential should be the best, and then I would say the residual plot shows no pattern. And that would be my answer for example 4. And then finally, sometimes given the context of a story problem, it actually may make sense to over or underestimate our predictions based on the context of the story. So for example 5, Mr. Herkelman hopes to make it into the Guinness Book of World Records by painting the world's biggest mural on the side of several downtown buildings. His mural will consist of many painted circles of various sizes. He wants to create a model to determine how much paint is needed for a circle of radius r in feet. What type of model should I use? So here I'm dealing with area, right? I'm going to be working with the radius, and then I need to know how much paint to get for the surface area. So this is probably going to be a quadratic model would be the best, and simply just because I am or are dealing with surface area, which is just going to be a units squared. Right, so that would be my answer for part A. After creating his model, I use it to purchase different special paint colors to use. In this situation, would it be more appropriate for me to over or underestimate the actual amount of paint I need? Give a reason for your answer. Here, it almost has like nothing to do with math. It's more just very general common sense. So here, I would say it's better to overestimate. And the reason why it's better to overestimate is because in terms of this story problem, you almost want to have too much paint rather than run out of paint and not have enough. So here I would say it's better to have too much paint versus run out of paint and need to get more. So that should be my answer for part B. All right, so that should be it for the e-learning. Hopefully it's a pretty quick and easy lesson. If you have any questions, please reach out via email, and I will be back for office hours when we get back from Thanksgiving. Have a good rest of your guys' break, and I will see you guys later. Thanks.